Hey, all, Brad here with another video. On the bench today, I've got a Robotron board set customer sent in. It's a complete board set minus the I/O board, but he did send a I/O board for a Defender in that he needed fixed. I think he had a Robotron and he had some different boards and was trying stuff, and these ones all had issues, so he sent them in. I'll show here the MPU had quite a bit of failed parts and components on it. Probably hadn't run in a long time, sat in a box is my guess, but we got it sorted out. So I will switch over to the bench cam and we'll go through what we did, and then we'll go through and do some diagnostic test and then some gameplay. So let me switch over to the bench cam. I've got my little finger pointer guy here. Whoops, sorry about all that. So I'll start here with the soundboard. So all the boards were pretty rough, dirty wise. So they all got completely stripped, all the labels removed, and they got a simple green bath. If you check the video, the link down below in the description, I've got a link to the images showing that. So I got all new electrolytic caps, a new bridge rectifier. The fuse gets removed. I clean these with some Scotch Brite pads and then kind of squeeze these so you get a lot of friction. It takes a lot of force to get the fuse in now. Sometimes these are like blown out where the fuse almost falls out. New electrolytics here, all new Molex headers with the square pins. We've got a new tantalum here, here, and here. And then on this board, which is unusual, most of these came with the tantalum in this location. This is audio AC coupling capacitor. This one had aluminum electrolytic, so I replaced it with the tantalum. I pulled out the EEPROM. This is an original label on it, and the CPU cleaned and straightened the legs on it, and I removed the heatsink from both of the amplifier and the voltage regulator, put new compound in there, and then again, everything got cleaned up real good. This is the I/O board for the Defender that I did. You can tell the Defender has a couple pins that were cut as keys for the connectors. But this got a new electrolytic cap, two new 10-pin Molex headers, and the ribbon cable, and it's fully tested on the Defender set. Um, as I mentioned, I do return all the old parts to the customers unless they specifically say, like, don't send them. um, anyway, there's the old battery holder, ribbon cables, and again, the MPU had a lot of bad components that I'll go over. IO board is just one I keep on my test bench for testing, and I'm using ROM board. This was non-working. The customer did buy a set of tie-dye ROMs for me that he tried on here, which did not solve the problem. So then he sent those with these on the board already. I pulled all the socketed chips, including the special chips here, the blitters, and clean, straighten the legs, put reproduction labels on those. The EEPROMs were in good shape. Those were new that I just sent out, a month or two ago. New electrolytic filter caps here on the power, new Molex headers, new 3M ribbon cable, all 3M parts that I build in-house. And then on this board, it had a bad 7474 Type T flip-flop. Um, these have bank switching for the addresses, and this is this particular output controls the bank switching on it, and so the board wouldn't boot or anything with this ROM board. So I got that sorted out. On the MPU, a lot of problems here. I'll start here with the simple stuff. So battery holder had the original AA with some corrosion, got that out. I always fill in these solder holes and clean things up as best I can. A lot of people run the ground over to this pin that goes to the negative side. I do it on the back side of the board. I only have to bridge a tiny little gap here between that connector and the ground bus that runs around the perimeter of the board. So I think it's much cleaner. And then we have a CR 2450 in here, which again probably has 3 times the capacity of the CR 2032s. And I think I mentioned before, but the numbers there is interesting. So a CR 2450 indicates that it's a 24 millimeter diameter by 5.0 millimeters thick, where a CR 2032 is 20 millimeters diameter, 3.2 millimeters thick. So you can always tell the size of the battery just by the part number, which is kind of slick. We had about 4 or 5 bad 4116 DRAM here that I changed throughout the process. The decoders were both good. I pulled and cleaned, straightened the legs, and I put reproduction labels on them. The original CPU had a lot of rotten legs on it, corroded, and one of them was just totally loose and thin, so I replaced the CPU. The socket had issues as well, so I got a new 40-pin socket. The CMOS RAM was bad, so I got new CMOS as well as a socket installed for that. Most of the parts when I change them, I don't use sockets, but the RAMs and CPUs, the parts that originally came socketed, I do. I do the CMOS because sometimes, in the future, if someone wants to put in an NVRAM module or this CMOS goes bad or something again, it's already socketed. And then new Molex headers across all 3 locations. New Nichicon filter caps for the -5, +12 regulated, and +5 regulated. We've got a new tantalum capacitor here, 22 microfarad for the soft start. Original one was an aluminum electrolytic. And then on this board, one of the shift registers here, these 166s had failed, so it was missing some colors once I got it to boot, so I changed that. And before it wouldn't boot here, for the video address generator circuit, there's a bunch of counters here, 4 of them, and the top 2 were bad. 2 of the outputs were bad on them. These are 74161s, so I replaced those. So this got a couple of those. It got an IC over here, CPU, CMOS, and then all the boards got a simple green bath. So we're in good shape now. Let me switch back and we'll get through some gameplay. Okay. What you're seeing on the screen besides me is just some artifacts on the CGA to VGA converter that I use. I do have a PlayStation controller. I've shown this in other videos, and I've wired it up to a system where I can load different configurations. I can remap these buttons for any game I want, including the analogs. I can emulate 49 ways or whatever we want to do. I also have a little remote control that I use to power up the bench here. And again, this is running on my bench all the Williams bottom transformer, linear power supply, the whole thing to simulate the game. So I'll hit power on. We'll see it go through here and run the RAM test. That carpet or rug pattern, again, is just anything that goes into the RAM gets rendered out to the screen. So what you're seeing with that carpet pattern is essentially the board running an application, an app, to test the RAM, and it just writes random data and reads it back and makes sure what it wrote out is able to read back. And just so happens that that's being rendered out to the display simultaneously. So you can see she boots right into attract mode, so that's telling us that the CMOS RAM is retaining settings and high scores, as well as the battery and all that's working. So let's drop into diagnostics, and we'll take a look. Whoops. Go through this real quick. So all ROM's good. So what it does here with that test, which also happens when you first boot the game, is it verifies the checksums from all the ROMs. So it reads the contents, calculates checksum, and stores those with checksums that are actually stored on one of the RAM chips. And then dropped into the RAM test, no RAM errors. Now we'll do CMOS, no errors there. We'll loop through some of the sound tests. Once you get to 6, it'll just loop back to 1 because we've essentially tested all the digital outputs on the ROM board at that point. And here's the switch test. So again, this is Robotron. So on my little remote here, we can do up, down, left, right, and then fire, up, down, left, right. We have coin and player 1 start, and then I have the diagnostic switches here, auto up, and then the advance will take us to the next screen. And then we can test the color RAM if we want. We'll see 3 intensities of red. You'll see it change, and then there'll be 3 intensities of green, and then 2 intensities of blue. It's an 8-bit system, right? So you get 8. So they used 3 for red, 3 for green, which is 6, and then 2 for blue. So you get a total of 8. And then we drop in here where you get the color bars. This is where you would set your convergence on the monitor, that sort of stuff. Then you get a solid red, green, and blue, and then color bars. And then we go into bookkeeping data. And then this is your configuration, your screen settings, where you can put all your track messages. And if you want free play or whatever, you can do all that settings here. And then we go right back into a track mode. So I will coin it up and start a game here. So I've got the controller here and try not to embarrass myself too bad. do it. Oh. So you can see she's playing real good, no issues. So I'm going to get everything wrapped up here. The board did have, probably had about 72 hours of runtime on it. So I'm going to go ahead and get everything boxed up and coming back to my customer Mike. So thanks for watching the video.